During this film, you will need to take down notes and readings from the screen. We're going to use this apparatus to measure molar mass. This is a boiling tube. A platinum pin at the base provides a location for smooth boiling. And this is the cottrell pump. There are 3 jets and a temperature measuring device can be mounted in the middle of them. The pump is placed carefully inside the boiling tube so that its funnel-shaped base covers the platinum pin. And a glass tube sleeve is placed around the pump. Now for the temperature measuring device. We use a thermistor. It has a tip sensitive to temperature change. When the tip is warmed up, its electrical resistance decreases and the resistance registered by this meter falls. Watch. It's now reacting to the temperature of a finger. Take the finger away and the temperature drops again so that the resistance rises. The units are kilohms, by the way, kilohms. The thermistor with its electrical leads is fitted into the top of the boiling tube so that its tip lies between the 3 jets of the cottrell pump. We fit a reflux condenser to the side arm so that no solvent can escape as vapour during boiling. The solvent we're going to use is tetrahydrofuran. Note that, tetrahydrofuran. We pipette out a 25 cc sample of the solvent. 25 cc's. Write that down. Now, first of all, we must take a resistance reading corresponding to the boiling point of the pure solvent. Boiling starts at the pin in the bottom of the boiling tube. Boiling solvent is spurting onto the tip of the thermistor from the 3 jets. Now for the resistance reading. We make it 12.996 kiloohms. There's a slight variation in the 3rd place of decimals as the temperature fluctuates. 12.996. Write it down. Now we're going to standardize the apparatus using benzoic acid. Benzoic acid, write that down. We make a number of pellets of the acid which are convenient to weigh. They'll be put in a sealed container until they're needed. Here's the first sample being weighed. The pellets have been broken into a few smaller pieces so that they'll pass down the sidearm. The balance has been zeroed or tared so that the weight of the piece of foil is allowed for. Get ready to write down the weight of this first benzoic acid sample. Here it is, 0.4929 grams. 0.4929 grams. Write it down. The apparatus is allowed to cool a little. Then we quickly remove the condenser, drop in the weighed pellets, and replace the condenser. The pellets start to dissolve. As they do so, the boiling point of the solution rises, so the resistance drops. Nearly all dissolved now. And the thermistor is sensing the temperature at the new boiling point. Write this down. Get ready. 12.78 something. We estimate the average is 12.785 kiloohms. Write it down. .785. Now we weigh out some more benzoic acid. Write this down, a further weight of solute to be added, another 0.6 something 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 grams. Put it down. We add that to the solution. Now estimate and write down the new reading for the boiling point. Lower because the temperature's higher. 12.5 something something. Get the average. We weigh out more benzoic acid. Write down this further weight, which we'll add to the solution. And against it, a new reading off the meter. Here it comes. 12.3 something something. Another lot of benzoic acid. Write down this weight. And this resistance reading, 12.0 something something kiloohms. Another sample of benzoic acid to make the solution even stronger. Write it down. And the corresponding resistance reading, 11.8 something something. Now for the last addition of benzoic acid, write down this weight. And the last resistance reading for this run, 11.56 something. We now clean out the apparatus and start again with a fresh 25 cc sample of the same solvent. Get ready to write down another set of readings. Once again, we'll start with a resistance reading for the pure solvent. It'll be slightly different from last time as conditions change during an experiment. There it is. Estimate it, write it down. 13.01 something kiloohms for the pure solvent. Here's the unknown solid whose molar mass we're going to determine. Once again, we make tablets, break them, and weigh them. Here's the weight of our first sample of X, the unknown solid. Put it down. We add the sample through the sidearm, and when it's dissolved, estimate the corresponding resistance, 12.8 something something kiloohms. Estimate the average value as usual. Now a further sample of X. Write down this weight. And the corresponding resistance reading, lower as the solution gets more concentrated. Estimate this, 12.6 something something. A further sample, put this down. And the resistance reading, 12.47 something. We weigh out another sample. Write this down. And here's the new resistance, 12.3 something something. The next weighing. Now the resistance, get ready to estimate it. 12.1 something something. The last sample of our unknown solid, a further 0.3105 grams. Write it down. And the last resistance reading, write this down. Now for a final experiment. Once again we start afresh with 25 cc's of our pure solvent in clean apparatus, and we take the resistance reading corresponding to its boiling point. Estimate it, write it down. We're going to add a liquid solute this time. Glacial acetic acid, note that, glacial acetic acid, ethanoic acid. Instead of weighing out the sample, we add known volumes of the acid to the solvent in the boiling tube. First reading 1.00 cc's, write it down. 1.00 cc's of ethanoic acid added. We set up the apparatus again. Get ready to estimate the resistance reading. 12.2 something something kiloohms. Now a further 1.00 cc's, making 2.00 cc's of acetic acid in all. Put that down and estimate this. Another 1 cc of acetic ethanoic acid. Estimate this. Another 2 cc's of acid, making 5 cc's in all. Write it down. And estimate this resistance corresponding to the new boiling point. Now 7.00 cc's of acetic acid have been added. 7.00 cc's, and here's the resistance for you. The next acetic acid sample, we've now got 8.00 cc's in all in the solution. 8.00 cc's. Estimate this and write it down. Finally, 9.00 cc's of acetic or ethanoic acid dissolved in the solvent. Now estimate this. And, using your readings and the notes in the experiment booklet, you can calculate the molar mass of the unknown solid and investigate the behaviour of the acetic acid.